it really is exactly what it sounds like. It means that at some point in your life, you're going to be taking a square root to solve. Now, that means, remember, that when you take a square root, I no longer accept rounded decimal answers. When you take a square root, you are going to have to simplify the radicals. All right? So we reviewed this yesterday, so let's see what you remember. So you may want that yellow graphic organizer out with your perfect squares on it.
That's not page. What page is that? Oh, I'm on page 32. That's not page 32. Page 32.
Hold up. What the? Oh, my bad. I was all the way at the bottom of it. There it is. It's page 32. My bad. Still page 32. I just had my screen was scrolled all the way down to the bottom. Yeah. All right. So when we solve by taking a square root, all right, that typically means we do not have a b value. So you can only solve by taking a square root if there's no b of x value. So in other words, instead of ax squared plus bx plus c is equal to 0, we would only have, if there's no bx value, ax squared plus c is equal to 0. All right, so you can only solve by taking a square root if you have no b value. Now, remember, whenever you solve by taking a square root, it's like you're essentially solving a linear equation like we're used to. So you really need to pay attention to the order of operations, or PEMDAS. All right, real quick, remind me what PEMDAS stands for. Parentheses, exponents, multiplication, division, and addition, subtraction. Now, that's our order of operations. But when we solve, you go backwards. So whenever you solve, think SADMEP. All right, that should tell you what you should start with. All right, so you would start by doing any kind of addition, subtraction. Then you would undo any multiplication, division. Take care of any exponents. And then take care of what's in the parentheses. So you would go backwards. All right, whenever you solve. So all of these essentially can be solved the same way. All right. The first one is just a simple two-step equation because it's linear. There's no x squared, it's just x. So this is review from Math 1. So what's your first step for solving this equation? Come on, I know you know how to solve a two-step. What is it? Add the 1 to both sides. So I have 2x is equal to 32. So we just did the essay of SADMEP. Then what do I do? Divide both sides by 2. So that's the dm of SADMEP. So x is equal to what? 16. Now, let's do that same process, but now we have an x squared. So remember, x squared, some of you may want to go ahead and take a square root, but why can we not do that? Where do exponents fall in SADMEP? Towards the end, right? So taking a square root should be one of the last things you do. So what will be my first step? If we follow SADMEP, we take care of the what? The addition, subtraction, which is the -1. So how do I move it? +1. So I get 2x squared is equal to 32. Now, this is where I see a lot of people mess up. They want to go and take a square root from there. Why can I not? Because you have multiplication to deal with first. So that's why I say follow SAD MEP. All right? You take care of addition, subtraction, then you take care of any multiplication, division, then you take care of the exponent. All right? So I'm going to divide both sides by 2. So x squared is equal to 16. Now I can deal with the exponent, which is the square root. So remember, a square root cancels out a square. So you have x is equal to, what's the square root of 16? 4. However, remember, whenever we solve and we take a square root, what did I say you always have to put in front of that value? Plus minus. Because remember, plus minus is just a fancy way to write out positive 4 and negative 4. That's what plus minus 4 means. It means it can be either positive 4 or negative 4. Because if you think about it, isn't 4 squared and negative 4 squared both 16? Yes. So we put the plus or minus there because we don't know which one they want. All right, either one will work. That's why we put the plus minus. So remember, if you ever take a square root at any point to solve, you got to take the plus, put the plus or minus in front of it. All right, does everyone understand that? So x equals plus or minus 4 is my answer. Now, this next one, this one looks like we're doing the full order of operations. So think SADMEP. This is where SADMEP will really come in handy. So if you think SADMEP, what do you do first? You add the 1, take care of the addition subtraction. So I have 2 times x minus 3 squared is equal to 32. What do you think I do next? We don't want to distribute, just for the sheer fact that we can't because of the square. Can't multiply, but we can take care of the multiplication. Where's their multiplication here? It's the what? Nope, that's not the multiplication. What number is being multiplied to something? 2. So I got to take care of this 2 by doing what? Dividing it. So you can't distribute that 2 because of that square. All right? The square is preventing us from doing that. So I have x minus 3 squared is equal to 16. Now, think SADMEP. So we did the SA part of SADMEP. We did the MD part of SADMEP. What does that leave me with next? Not parentheses. Exponents. So I need to take care of that square first before I take care of what's inside the parentheses. So how do I take care of the square? Square root. So x minus 3 is equal to what? Not just 4, plus or minus 4. And then finally, to get the x by itself, what do we need to do? Add the 3 because it's out of the parentheses now. So x is equal to plus or minus 4 plus 3. Now, you're probably wondering, what the heck do I do with that? Well, all you got to do is split it apart into 2 little abbreviations. So I have positive 4 minus 3 and negative 4 minus 3. So you should get 2 answers. All right. So what's 4 minus 3? 1. What's negative 4 minus 3? Negative 7. So x is equal to the set of negative 7 and 1. So whenever you have to deal with something in parentheses at the end, make sure that you separate the plus minus into its positive version. And it's, I don't know why I wrote minus 3. That's definitely a plus 3. My bad. So that should be 7. That should be negative 1. That is my bad. So we just flip-flop. So it also helps if you write the correct sign. So yeah. But that's what you should do if you ever had to add anything else over after you take the square root. You just separate the plus minus number into its positive version, its negative version, and you add 3 to both of those versions. Or add or subtract whatever they want to both those versions. Does that make sense? Good. Now, let's do some radical review real quick. So we talked about this yesterday. Simplifying radicals. What's my first step to simplify 72? Nope. Kind of. It involves that gold sheet that I gave you guys. What's on your... Right. You got to find the greatest perfect square that can go into 72. So what is the greatest perfect square that can go into 72? 36. And 36 times what is 72? 2. So remember, I can rewrite this as the square root of 36 times 2. Then what can I do? Right, we can separate the square roots. So I have square root of 36 times the square root of 2. What's my last step? Take the square root of 36. So what is the square root of 36? 6. Square root 2. Now, the reason we don't have to put plus or minus in front of this one is because we're not solving, we're simply simplifying. All right, it's usually when you're solving that you have to put the plus or minus in front of it. All right, so that would be our answer. Now, that's simplifying. Now let's talk rationalizing the denominators. So we also talked about this yesterday. Remember, we do not like square roots in the denominators of a fraction. So how do I get rid of it? Not quite, but you're close. You got to multiply something. You got to multiply the square roots to what? Right. So we take whatever's in the denominator, and we're going to multiply the numerator and the denominator by the square root of 2. So what's 1 times the square root of 2? 1 square root 2, or just the square root of 2? Yep. So remember, you can't multiply a number that's not under a radical by a number that's under a radical, although it doesn't matter with 1 anyway. But let's say that was a 3. Don't multiply it to the 2. You just smush them together. So this is technically 1 square root 2. What's the square root of 2 times the square root of 2? Square root of 4. So since they're both under a radical, you can multiply those two numbers together. Put the phones up. And then we just got to do some simplifying. So we can't simplify the top. But what's the square root of 4? 2. Can't simplify anything further because there's nothing outside of the square root of 2. And we can't touch the 2 under the radical. So that's our answer. All right. Now, this one. So we have a fraction under a radical, which we don't like either. But what did I say yesterday that you can do to that fraction? So if you have a fraction under a radical, what can I say you can do to that fraction in the radical? It's similar to multiplication. You can do the division, but what specifically? Look at your notes from yesterday. What did we do with that? We did what? What do we do? It's one of the last things we did yesterday. What did we do? Guys, it's literally written down your notes. Look. Or it should be written down your notes. Not quite, because we can't rationalize because there's not just a singular square root in the denominator. We can, there you go. We can separate the radical into two separate radicals. So just like with multiplication, how I can separate multiplication under a singular radical into two radicals, I can separate division the same way. So I can do the square root of 144 over the square root of 9. And then I can simplify from there. So what's the square root of 144? 12. What's the square root of 9? What's 12 divided by 3? 4. So multiplication, division, you can do the same thing. So just like how you can separate multiplication into two radicals, you can separate division into two radicals. Yes. No, the 4 is pretty much done. Because the square root no longer exists, so we can't like take the square root of 4. All right, this one. First step. So we have a fraction. What can I do? Not yet. What did I just do here? You split it up. That's what I'm doing first. So I have the square root of 8 by the square root of 20. Now, my recommendation, simplify the radicals first. All right? So what two values can I split 8 into? 4 and 2. So I have the square root of 4 times the square root of 2 over, what can I separate 20 into? Square root of 4, square root of 5. Oops. Just want to write 4 and 5 there. So this is square root of 4 times the square root of 5. Now, we don't even have to simplify the square root of 4 because what happens? It gets canceled out because you have one the top, one the bottom. So we're left with the square root of 2 over the square root of 5. Now what do we have to do? Because we have a square root in the denominator, which we don't like. So what do we have to do now? Multiply what? To what? Both the top and the bottom. So what's the square root of 2 times the square root of 5? Square root of 10. Because since they're both under the radical, we can multiply those numbers. What's the square root of 5 times the square root of 5? Square root of 25. Now, if we simplify square root of 10, is there any perfect square factors in the square in 10? No. The only other factors of 10 besides 1 and 10 are 2 and 5, neither of which are perfect squares. So square root of 10 simplified to its fullest. However, what's the square root of 25? 5. And with that, we're done. So, now remember, because the 10 is under the square root, we cannot divide the 10 by 5. All right? So don't touch the 10 under the square root. Any questions on that stuff? That's just review. Now, here are the steps for taking a square root. So we're going to do some more of these. So you got to isolate the x squared or the parentheses that's being squared, where a can be any rational number. So remember, you're doing that through SADMEP. Once you get the x squared isolated, you can take the square root to get rid of the square. And then finally, remember, you have two possible solutions. All right, the positive version and the negative version. So remember, that's that plus minus that you got to put in front of whenever you take a square root. So that's why math people create signs like plus minus, because we don't have to write out two different things, so we shorthand it. So let's start with some very, very, very easy ones, where all we got is x squared equal to a number. So the x squared's already isolated. So what can I do to solve? So the x squared's isolated, so how do I get rid of the square? Square root. So I'm just going to square root both sides. That's gone. X is equal to what? Plus or minus 10. The square root of 100 is plus or minus 10 because it can either be positive 10 or negative 10. What about this one? Square root both sides. Can we simplify square root of 7 any? No. So x is equal to plus or minus the square root of 7. So even though the square root of 7 can't simplify, it's not a perfect square, you still got to throw that plus or minus in front of it. Because we're saying it can either be positive square root of 7 or negative square root of 7. All right, this last one, what do I do? Square root it. So I have x is equal to plus or minus the square root of 20. Now, 20 is not a perfect square, but can we simplify it? Yeah. So what is the perfect square factor in the square root of 20? 4. And 4 times what is 20? 5. So I can rewrite this as x is equal to plus or minus square root of 4 times the square root of 5. So x is equal to plus or minus what? What's the square root of 4? 2 times the square root of 5. So guys, if you can simplify the radical, I want it simplified. All right. So if the radical is capable of being simplified, meaning there's a factor of that number that is a perfect square, I want you to simplify the radical. Now, those were very, very easy ones. Now let's look at some where we got to do an extra step. Let's look at example 4. Now, if we're talking SADMEP, if we look at the left side of the equal sign, if we're talking SADMEP, what do I have to take care of first? The exponent or the 6? The 6. Why? What operation is the 6 doing to the x squared? Owen. It is multiplying. Yep. So since the 6 is being multiplied, in SADMEP, multiplication comes before exponents. So I got to take care of that 6 by dividing it to both sides. So x squared is equal to, what's 48 divided by 6? 8. Now what can I do? Square root both sides. So that goes away. X is equal to plus or minus the square root of 8. Can I simplify the square root of 8 any? Yep. What is my perfect square factor in 8? 4. And that's times 2. So x is equal to plus or minus the square root of 4 times the square root of 2. What's the square root of 4? 2. So plus or minus 2 square root 2. Take a second, try example 5. All right, I'll leave example 4 up as an example, as a reference, but try example 5. So guys, maybe leaving it as a fraction will help you. So when you divide the 4 over, maybe leave it as a fraction when you take the square roots. Intent, wait. All right, guys, 1 more minute. I'm gonna talk. All righty, my darlings. All right, darlings. Let's come back together. So, what is my first step, Kyrie? Divide both sides by 4. So x squared. Now, 121 cannot be divided by 4 evenly. So I'm going to leave it as a fraction. So guys, when it comes to taking a square root, do not change it to a decimal. If it doesn't go in evenly, leave it as a fraction. You'll see why in just a second. All right. What's my next step, Kaylee? Well, I'm at x squared, so how do I get rid of it? We take a square root. Good. So I have x is equal to plus or minus the square root of 121 over 4. Now, guys, from here, what can I do with this square root of a fraction? Not just simplify, but couldn't I do something with it? Square root what? You can split apart the square roots. Because aren't 121 and 4 both perfect squares? Yes. So x is equal to plus or minus what? What's 11 over 2? Square root of 121 is 11, square root of 4 is 2. And I'll leave it just like that. All right, so that's when you only have to do one more operation before taking the square root. Now let's look at when we have to do 2. So look at example 7. What do you guys think my first step is? Adding the 25. By the way, guys, this one you could factor by a difference of squares and go that route. All right, there's more than one way to skin a duck. All right. So 9x squared is equal to 25. What's my next step? Divide by 9. Good. Now, does 9 go into 25 nicely? No, so we're going to leave it as 25 over 9. What's my next step? Square root both sides. So x is equal to plus or minus the square root of 25 over 9. What can I do with that square root of a fraction now? Square root each individually. So we break apart the perfect square. Not the perfect square, we break apart the square roots. So x is equal to plus or minus what? 5 over 3. Good. Any questions on that one? So again, guys, my recommendation, whenever you divide and you know that number is not going to be divisible by the number that you're dividing by, just leave it as a fraction. Do not try to put a decimal in there. Because trust me, that gets way too precarious. Let's try this one. What's my first step? Add the 20. So I have 3x squared is equal to 20. Then I do what? Divide both sides by 3. Now, will 3 go into 20? Nope. So x squared is equal to 20 over 3. And then I do what? Square root both sides. Now, I'm going to go ahead and separate this fraction into 2 square roots. So I have x squared is equal to the square root of 20 over the square root of 3. And forgot the plus or minus. Now, neither the square root of 20 or the square root of 3 gives us nice numbers. However, what can I do to simplify? Well, it's already broke apart. We can simplify the 20, but I would do something else first. What do we not like in the denominators of fractions? The square roots. So I need to get rid of that square root in the denominator first. How? We're rationalizing the denominator now, so what do we do? Guys, what did we do on the previous page?
I take the 3 and put on both the bottom and top, right?
Right, we just multiply by whatever radicals in the bottom to the top and the bottom. So what's the square root of 20 times the square root of 3? Square root of what? 60 over. What's the square root of 3 times the square root of 3? Square root of 9. Not 9, but square root of 9. Different numbers. So x is equal to plus or minus square root of 60 over, what's the square root of 9? 3. Now, is there possibly a perfect square factor that can go into 60? Yeah, there is. What is it? 12 is not a perfect square. 4 is. And you can't get higher than that. So you got 4 and what? 15. So I can change this to the square root of 4 times the square root of 15 over 3. So we just leave the denominator alone for right now. But what's the square root of 4? 2. So x is equal to plus or minus 2 square root 15 over 3. Is there anywhere else I can simplify? No. The 2 over 3, 2/3 is a simplified fraction fully, so we can't simplify that, so we're done. So guys, sometimes the solving part is the easier part, but then you have to do some simplification at the end. So you got to be able to use those simplification methods that we talked about to do so. Yes, sir. Yeah. Now, those were doing 2 steps before taking the square roots. Now let's look at when we got some parentheses. So some binomials squared. Let's look at example 10. So if we follow SADMEP, what do I have to take care of first? Do I have to take care of the +1 or the square? Traditionally, yes, we would take care of that first. But what's true about that +1 for the reason why we can't touch it yet? It's in parentheses and it's squared. So the squared also prevents us from doing that. So biggest thing is that it's in parentheses, which we know exponents come before parentheses in SADMEP. So what do I have to do first? Square root both sides. Crap. I hate when it does that. So we're going to square root both sides. Because remember, this square root on this side is just going to get rid of that little 2. So we're still left with x plus 1. And then what's the square root of 16? Not just 4. Plus minus 4. Don't forget the plus minus when you're solving. Now, I can get the x by itself. How? Minus the 1. So I have x is equal to plus or minus 4 minus 1. Now, what did I say you can do to finish simplifying that? So we did one like this a little earlier. What do you do to take care of that plus or minus? So we can get 2 different number answers. What does plus or minus 4 represent? -4 and +4. So can't I break it apart? So do +4 and -4 and then subtract 1 to both? Can I do that? Yeah. That's what you do. You break apart the plus minus and then do the operation to both. So what's 4 minus 1? 3. So x is equal to 3. What's -4 minus 1? -5. So x is equal to -5. So x is equal to the set of -5 and 3. So that one was a nice number. All right. Let's look at example 11 now. So if we follow what we did in the first one, what do I do first? Square root both sides. So that goes bye-bye. I'm left with x minus 3 is equal to plus or minus the square root of 12. Now, before we move the 3 over, I would just go ahead and simplify the square root of 12 just to get it out of the way. All right? Because obviously when we add the 3 over, it can't be actually added to the 12 because 3 is not under a radical. So how can I simplify 12? What's my 2 perfect squares? 4 and 3. So I got plus or minus the square root of 4 times the square root of 3, which is what? Plus or minus what? 2 square root 3. And it's equal to x minus 3. Now, what do I do next? Add 3 to both sides. So this would be x is equal to plus or minus 2 square root 3 plus 3. So we can't add the 3 to the 2 because it's connected to the square root of 3. We can't add the 3 to the 3 because of the square root of 3, it's under a radical. So we just got to kind of throw it on at the end. Now, that's literally your answer. You can leave it just like that. All right, because that represents an irrational number. So this represents an irrational number. And it's an exact irrational number. So it's an exact irrational number. Actually, it's numbers. Another way I can rewrite if I want to prettify it, I can move the 3 to the front of the plus minus. So I have 3 plus or minus 2 square roots 3. So we can leave that as our answer. And remember, that is technically 2 answers because if I split apart the plus or minus, I have 3 plus 2 square root 3 and 3 minus 2 square root 3. So that's 2 different irrational numbers. All right. Now, these last 2, these are basically just perfect square trinomials. All right. So remember, we talked about this when we were factoring special cases. Perfect square trinomials just means that you have a squared minus 2ab plus b squared. All right. So is it true that the first and last term are perfect squares? Is that true? Is x squared a perfect square? Yes. Is 16 a perfect square? Yes. And then if you take the square root of 16, so let's go ahead and take those square roots. So get my a and b. So what is the square root of a squared? What's the square root of x squared? X square root of 16? 4. So if I multiply 4 times x together, and then I times that by 2, does that give me 8? Yes. And even if it's negative, that's okay, because negative 4 times x, same thing. So who remembers how I factor that? It has to do with these values and then something else. So it'd be x and 4. What goes in between? A minus. Why a minus? Because it's the second sign. So it's the sign of the second. So the way you factor perfect square trinomials, you take the square root of the first, square root of the last. Those are your 2 values in the parentheses. Then you bring down the sign of the second term and make sure it's all squared. Equal to 1. So what's my first step for solving? Square root both sides. So I have x minus 4 is equal to, what's the square root of 1? What's the square root of 1? Plus or minus 1. Then I add 4 to both sides. So I have x is equal to plus or minus 1 plus 4. So what do I have to do to finish this up? So we do 1 plus 4 and then negative 1 plus 4. We don't have to flip the sign of the 4, just the 1. So what's 1 plus 4? Negative 1 plus 4? 3. So x is equal to the square of 3 and 5. Now, guys, if you didn't get that, you could have also just solved that by factoring. So subtracted the 1 over to the other side. That would have given you something factorable, and you could have factored that too. Like I said, there's more than one method that can work. Okay, so that's solving by taking a square root. Now let's look at when we have to do some completing the square. So, do you guys remember back in Unit 3 when we were going from standard form to vertex form and we had to like complete the square? Like, do you guys remember when we did that activity with all the algebra tiles where we were moving things around to actually make squares? Yeah. So, we're coming back to that. So, completing the square to solve a quadratic. The process is very, very similar to what it is to convert to vertex form. So, first off, you got to have x squared plus bx is equal to c. And the leading coefficient must be 1. That's why it's not ax squared, it's just x squared. So in other words, that just means move c to other side of equal. Then we're going to replace c by doing b over 2 squared. And we're going to take that b over 2 squared and add to both sides of the equation. Yes. Quickly. So, let's just kind of work through this together. So we start with this, x squared plus 6x minus 16. So I'm going to rewrite it right here. X squared plus 6x minus 16 is equal to 0. Now, they want us to rewrite the equation so that the constant term is on the right side. So what's my constant here? 16 or negative 16. So how do I move the negative 16 to the other side of the equal sign? You add it. So this would be x squared plus 6x. Remember, I like to leave a big space here so that I know I have to fill that in. Is equal to 16. And I'm going to put space next to the 16 as well because that's going to remind me when I do my next step. So it says find the value that's half the linear coefficient and add to both sides. That's literally just b over 2 squared. So it says find b over 2 squared. What's my b value? So what's my b value of my equation over here? Not 6x, just 6. Remember, we don't want variables. So I'm going to do 6 divided by 2 and then square it. So what's 6 divided by 2? 3. Squared. What's 3 squared? 9. So this is what I'm going to fill in the blanks with. So add 9, add 9. So if I rewrite, I'm going to rewrite in C, x squared plus 6x plus 9 is equal to whatever 16 plus 9 is, which is 25. Now I'm going to factor the left-hand side. So it should now be a perfect square trinomial. So you can use the trick that I gave you, which is square root the first, square root the last, separated by whatever the sign of the second is. And then you can write it in the bracket squared, parentheses squared. So what's the square of the first? X. What sign do I put here? Plus square root of 9, 3. Or set equal to 25. Once we get here, don't we already know how to solve that? Did we already do something like that? Yeah. So from here, we can just solve the equation. So I'm going to rewrite it over here. So x plus 3 squared is equal to 25. What's my first step for solving? So SADMEP, what do I take care of first? The exponent. How I get rid of it? Square root both sides. So that goes away. I get x plus 3 is equal to, what's the square root of 25? Not just 5. Plus or minus 5. We're in solving land, so the plus or minus is now relevant. Now what do I do? Minus the 3. So I have x is equal to plus or minus 5 minus 3. And I'm not done yet. What do I have to do finally? Right, I gotta separate them into the positive version of 5 minus 3 and the negative version of 5 minus 3. What's 5 minus 3? 2. Negative 5 minus 3? Negative 8. So x is equal to the set of negative 8 and 2. So I'll be perfectly honest, solving by completing the square I hate. I hate doing it, but I have to teach it to you because it's kind of a prelude into quadratic formula, which we do tomorrow. But in my opinion, quadratic formula is actually easier. All right? Mainly because what we're doing now is completing the square where the a value is 1. It's when they start having a values that are not 1, and then the b values are odd. That's when it starts getting to be a pain in the butt. All right, but we're not going to do any of those in this class. So let's try another one together. So look at letter A. Now we're going to take all the steps that we did up top, do it together. So what's my first step to solve by completing the square? Minus the 9 to both sides. So I have x squared minus 10x, leave a space, is equal to negative 9. And I'm going to also leave a space there, just so I know I need to put my next step there. What is my next step? What do I have to find? The b over 2 squared. What's my b value in this case? Not just 10, negative 10. Divided by 2 squared. What's negative 10 divided by 2? Negative 5. And what's negative 5 squared? Positive 25. So I'm going to add 25 to both sides. So I got to fill in both of those blanks. Oops. So if I pretty it up a little bit, x squared minus 10x plus 25 is equal to negative 9 plus 25 is what? 16. So now I got my perfect square trinomial on the left. So now what do I have to do with it? What was the next step that we did up top? Square root the x squared, square root the 25, and what? Bring down the negative. So in other words, we got to factor that perfect square trinomial. And again, guys, if you forget how to factor that, just do big X like we've been doing. So if you forget the tricks, just do big X. It works just as well. But just be careful because you will get the same factor times itself twice. You need to make sure you rewrite it as the same factor squared. So what's the square root of x squared? X square root of negative 10x. Or sorry, I bring down the negative. What's the square root of 25? 5. And I bring down the equals 16. So I finished completing the square. So now I'm in solving land. What do I do first to solve? Square roots, both sides. That goes bye-bye. I have x minus 5 is equal to what? Not just 4. Plus or minus 4. Get in the habit of that plus or minus. Then what do? Add the 5 to both sides. So I have x is equal to plus or minus 4 plus 5. I'm not done because both of those are nice rational numbers. So what do I have to do next? Right, 4 plus 5, negative 4 plus 5. So I break apart the plus minus. What's 4 plus 5? Negative 4 plus 5? 1. So that means x is equal to the set of 1 and 9. Any questions on that? Try letter B on your own. So I'm going to leave this up for reference. Try letter B on your own. And it's okay to get a radical that doesn't simplify, or if you get a radical that does not give you a perfect square. So I left A up for reference. Everyone should be trying letter B using the same method. All right, guys, we heard a lot of talking, so I'm assuming you're done. Are you done? Okay. All right, let's go over this. So, what is my first step here? Add the 21 to both sides. So that goes away. I get x squared plus 4x. Leave a big space. Is equal to 21. Leave a space. What do I do next? B over 2 what? Squared. What's my B value in this case? 4, so 4 divided by 2, square it. So that would be 2 squared, which is what? 4. So I'm going to add 4 to both sides. So I'm filling in those 2 blanks. So guys, like, you don't have to put the blanks, but I highly recommend it just so you know something has to go there. All right. So if I clean this up a little bit, I got x squared plus 4x plus 4 is equal to 25. What's my next step? So in other words, factor. So I square root the first, keep the sign of the second, square root the last. So what would this be factored? X plus 2 squared. Is that equal to 25? All right, so I finished completing the square, so now I'm in solving land. So what's my first step to solve? Take the square root of both sides. That cancels. I get x plus 2 is equal to what? Not just 5, plus minus 5. And guys, I'm being a stickler on that because the more I'll say it, the more you remember it. All right? So then what do? Subtract the 2 to both sides. So I get x is equal to plus or minus 5 minus 2. What's my final step to finish it up? Break apart the plus minus. So I have 5 minus 2, negative 5 minus 2. What's 5 minus 2? Negative 5 minus 2. So x is equal to the set of negative 7 and 3. Any questions? All right, so that's it for today. Your homework assignment or classwork, whatever you want to call it, you got about a solid 15 minutes. It's another delta math. And what I did to help you guys with completing the square, there's like 2 of the delta math sections that actually break apart the steps for completing the square for you so that you can practice those steps. All right. So within this 15 minutes, I expect you guys to have your Chromebook out working on this. Say it one more time.